So this is the follow-up to that double displacement reactions video. And this is the first type that I mentioned, the neutralization reaction. So I want to make sure everyone's clear. Basically, in a neutralization reaction, the acid is going to give us a proton. A proton is just a hydrogen ion, and the base typically gives you the hydroxide. And we'll see that the two of those form water. Water is neutral, so when you have acid and base in equal amounts, they neutralize each other. So that's what a neutralization reaction essentially is. So the general form of this equation is we have an acid, we add it to a base in equal amounts, and we produce water and a salt. And again, a salt is basically an ionic compound. So one example is we have hydrochloric acid with sodium hydroxide producing H2O and NaCl. So if you recall with the do-si-do example, I write out kind of each couple, and I'm breaking down the hydrochloric acid into the ions that are going to separate in solution, and that's what aqueous means. Aqueous means it's dissolved in water. And I'm going to do the same thing with the base. I'm going to get the sodium ion and the hydroxide ion. And when I think of the do-si-do, remember I'm switching partners. So I'm taking the H plus from the acid and the hydroxide, the OH minus from the base, and what am I making? I'm making water. Now, I like to write out HOH, because that actually will, you'll see down the line, help me balance it, because that's what H2O is, right? If you look at HOH, there's two hydrogens and one oxygen. But I like writing it out as HOH because we're getting the H plus from the acid and the OH minus from the base. And what would be the other couple? The other couple would be the salt, the sodium chloride. And it's a +1 for the sodium ion, and it's a -1 for the chloride. So I get the NaCl. So that's essentially your neutralization reaction. Now, a lot of times you'll see acids written out as HA. And why is that? Well, you know, they're showing that the H is what gives me the proton. And a lot of times they'll write the base out as BOH. Another way to write it out is a general formula. Why? Well, the base is hydroxide is what makes it a base. And then you see that I wrote it as HOH, and then what would be, you know, left over, the B and the A would be my salt. And again, the HOA is just another way of writing out water. So these are kind of the easiest reactions, well, actually combustion, but these are pretty easy reactions to determine the product. So if I look at hydrobromic acid, I right off the bat know this is an acid. Lithium hydroxide I know is a base. So I recognize this is a neutralization. Right away, this is going to be a double displacement reaction. So what am I going to do? I'm going to separate the ions because it's aqueous, it's in solution, it's going to dissociate. And I'll do the same thing for my lithium hydroxide. And then I'm going to do what? The do-si-do. So what do I end up getting? HOH, which is my water, and lithium bromide. Now, why is lithium bromide 1-to-1? Well, it's lithium's a +1 and the bromide's a -1. So when I go to balance this, it's kind of easy if you do it my way, because first I would go to metals, 1 lithium on this side, 1 lithium on this side. Then I go to nonmetals, 1 bromine, 1 bromine. And if I leave it as an HOH, I see here's an OH for my base as a polyatomic anion, and here's an OH in my water. And I got 1 OH here, and I got 1 OH here. That's actually balanced. So the only thing left is the hydrogen. And I have 1 hydrogen here, 1 hydrogen here. This equation is balanced. Now, why am I showing you using the HOH trick? Well, I'm hoping that you'll see its usefulness in this next example. So in this next example, I want you to go ahead and put pause and balance this out using the OH example. Okay, I'm assuming that you tried and balanced this out and you had put pause and hit play again. So we'll go ahead and separate the hydroiodic acid. I have an H plus and an I minus. Now with calcium, this is a 2 plus. And the hydroxide's only a -1, remember? And that's why we have to have 2 of the hydroxides. So when we do-si-do, okay, we still have the HOH for the water. And now for the calcium iodide, right? If calcium is 2 plus and iodide's -1, if I crisscross, I get calcium iodide. Okay, but now I have to balance it. So when I balance it, first metals, 1 calcium, 1 calcium. Then I go to nonmetals. There's 1 iodide here, but there's 2 here on the product side. So what do I need to do? I need to put a coefficient of 2 in front of the hydroiodic acid. Now I get to hydroxides because I'm saving hydrogen for last. And if we see in calcium hydroxide, that subscript means there's 2 hydroxides. And using that OH, I could see that there's only 1 OH on the product side. So I could put a 2 here to balance my hydroxides, and then saving hydrogen for last, now I have 2 hydrogens here, I have 2 hydrogens here, I'm balanced. So again, that's why I like that little HOH. You don't have to use it, you can do whatever you need. That's just a trick that I hope is helpful. So if you have any comments, go ahead and leave them in the comment section, and thanks for watching. I hope that helped.